Okay, this is the ambiguous case of the sine rule. And the word ambiguous means it could have, two meanings. So let's just look at this for a second. It says, we're a written problem. It says two sides and an acute angle. So I've got this triangle ABC. I'll draw it out. A, B, C. I don't know if it's to scale or whatever. And it says A, so the side across from here is 12. And the side across from the C is 8. And ACB, this angle here is 35 degrees. Okay? And I'm wondering how to find this picture in a way. And my point is this. I think that I could have found, well, let's do it this way. Let's look for this angle A here. Let's try that. Okay? Hang on one second. We'll do A. Sorry about that. I just wanted to put my rule down. So I have sine 35 over 8 and sine A over 12. And when I do this problem here, I get sine 35, remember to be in degrees, divided by 8 times by 12. And I get that sine A, I'm going to put it over here, sine A equals 0.860, let's just say 4. And that's what's on my calculator right now. Now I know from solving that the sine of something positive could be here or it could be here. It could be an acute angle right there. So let's find that acute angle. Wish I could get out of the glare there. I'm going to do second sine of that number, and I get 59.36, let's say. So this angle here is 59.36 degrees, but I know that there's another answer. I mean, I know that if this angle is also 59.36, that I could do 180 minus that, and that would make this equation work as well. So 120.64. This angle here. Right, so if I had been given this, right, and asked to find the angle A or determine the angle A, I could have had a situation where, in fact, I had an acute angle down here and it was 59 degrees, or I could have had a situation where I had 12 and C, and this angle here I won't put 64, I'll put 121 just to save us the pain of decimals. That could have been the triangle. So I could have a triangle ABC with one side 12 and one side 8 and one angle 35, and it could give me two different pictures, one with an obtuse angle and one with an acute angle. Okay, so let's look at that. When should you use the ambiguous case? Well, if you have a problem where the given angle is acute and the adjacent side is bigger than the opposite side. Okay, let's look at that again. The angle was acute. This was the given angle. And it says the adjacent side is bigger than the opposite side. The adjacent side to 35 is bigger than the opposite. So 12 was bigger than 8. And the opposite side must be bigger than the adjacent side times the sine of the given angle. So that's kind of hard. So let's do one where that works and one where it doesn't work. All right. I'm going to pause for a minute and get this set up, and you try to set up the triangle here as well. In fact, try to do this problem, and when you come back, I'll have it done. Okay, I'll just go through what I did. I set up a triangle where I had an angle of 40, an acute angle, and the side across from that acute angle was 10. And then I had, I think, maybe another acute angle here, and the side across from that was 15. And then I set up my sine rule, and then, I'll put this over here, to figure out sine C, I do second sine 0.9642, and I come up with C being equal to 74.6. Okay, now if I do 180 minus 74.6, I get that C could also be 105.4. Okay, so I could have drawn the triangle in such a way that it looked like, my pencil just broke, that it looked like A here was 40, and C is here, 105. And this is still 15, and this is still 10. So both of these possibilities exist. What do you have to do? You have to know that when you subtract this from 180, you get the other angle. You should put degrees. Okay, now let's look at this one that doesn't work. It says, in this triangle XYZ, I have x equal to 70. I'm drawing it out really sloppy. 70 degrees. And the side across is 45 meters. And Z, this is x, sorry, and Z is 35 millimeters. This should be both millimeters, sorry girls. I'll make this one Z this time. And this is 35 millimeters, and I'm looking for that angle. So, I'm going to say, all right, let's see, what do I have here? I have sine of Z over 35 equals sine of 70 degrees over 45. So I'm going to go into my calculator, and so you can see it, and do this equation. I'll clear out so you can see. So I have sine 70 divided by 45 times 35. So I have sine of Z equals 0.7309, about. So I go second sine of that, and I get Z equals 46.96. All right, so the other angle would have to be 180 minus that. Which is 133.04. All right, well, if I look at this triangle, and this angle's 70, and this angle is 133, that's already 200 degrees, and the triangle can only have 180. So this is that last little gig here, right? Up here, it's the last stop point. It turned out that when I did the multiplication, I got something so that when I subtracted from 180, I got an angle that's too big. So this is the only answer that can happen. So at the end, you have to figure out, do I have something that's bigger than 180 already, and there's no room for any other angle here? Okay, I hope you're all right. I think we gave you problems to do. I'm not positive, but you should try. There's not very many problems. It's 1 to 16 and 9.3. I'm sure that if you go into Miss Weidell's plan, or if you go into Miss Weidell's PowerPoints, she might have given a little bit less, but I think you should try these. All right, see ya.